Good afternoon, everybody. Rob here from the DAE. Thanks for tuning into our afternoon stream. I hope you enjoyed the stream this morning with Emily. She did an awesome job drawing with Scratch. So today, we're going to continue our exploration of Python, but we're going to change gears a little bit. So for the past couple of days, I've been doing lessons in Python. We looked at making a quiz. We looked at experimenting with lists with our automatic random sandwich generator program. And then we started drawing with code using Turtle. We're going to continue to draw with Python today. However, we're going to switch programs. So we're going to start looking at a program called processing. Processing is one of my favorite programs we teach. Processing was a program designed specifically to make creating visual art with code simple and easy. It was designed by visual artists that wanted to use computer science to play a role in the visual art that they create. So as a result, processing was created. It is free and open source, and it handles graphics very, very simply. So before we get started, I want to talk a little bit about how to get processing installed on your computer and get it set up properly. So this is what the processing window looks like. It looks just like a simple compiler window. We have a little play button and a stop button to run and stop our code. The only difference right now with processing compared to idle is that processing can handle multiple programming languages. So for example, right here you can see that we're writing code in Java mode. I can actually switch that into Python mode, and it switches processing to handle Python instead of Java. There are actually a bunch of different modes for this. The other thing that's really cool is there are like tons and tons of different libraries that you can import to handle sound, to handle video, to handle all kinds of different components. It's all open source. It's libraries that people create, which is really cool. So really quickly, I have processing.org opened up here in this browser window. All you would need to do to download processing is click the link that says download processing, and you choose your operating system. I've obviously already done that, so I'm just going to switch back to my processing window. Now, by default, processing doesn't come set up to handle Python. It, by default, is written in Java. If you click on Add Mode, we can then download different modes. There's a Python mode, there's a JavaScript mode, there's also an Android mode, which apparently allows you to create projects and then export them in a format that can be loaded onto an Android phone as an app. I've never done that. I don't know exactly how that works, but that was added in the last couple of years, and apparently it works pretty well. But at any rate, if you would need to install the Python mode, you would simply need to click on Python mode for processing and hit install. It would install that library and then, or that mode, and then we'd be able to switch to Python mode right here. So before we get started in using processing, I very quickly want to open up the Python processing documentation. So for processing mode with Python, I want to go to the reference manual and open this up. I want to have it open in the background because, as you saw with our Turtle lesson that we did yesterday, I'm no computer science expert and I forget a lot of things and I write things incorrectly all the time. So I keep my reference open because if I forget how to write something, I can easily come here, check it out, and figure out how to write that correctly. So I'm just going to keep this open in the background. I'm probably going to make a bunch of mistakes, as I've mentioned in the past. I don't have any professional background in computer science. I didn't study computer science in school. I learned it as an adult, and I have a lot of fun with it, and I'm totally a hobbyist. I'm no expert. I don't use it nearly as often as I wish I did. So I'm no expert. I'm just sharing my knowledge and experience that I've gotten over the past couple of years of working with code. So let's get into this, and bear with me if I make a couple of mistakes, because I probably will. But that's the cool thing about computer science is it doesn't have to be perfect, right? You can always iterate on it. It's probably not going to work the first time. Your code's probably not going to work the first time. So we can iterate on that. So I'm just going to make the font a little bit larger so it's a little bit easier to see. And so here's our sketch window. Processing projects are called sketches. So I've got my sketch. I'm in Python mode, so I'm going to quickly save this. And I'm going to save it as, let's save it in the documents folder. And I'm just going to call it Rob Processing 1. So with processing, I can write some code and immediately get some shapes on screen. But before we do that, I want to do a little bit of setup. So processing, when you really get into using it, has two main functions that run. I'm going to set them up, and then I'm going to explain how they work. So the first one is def setup, and then def loop. Oh, I'm sorry, def draw. It would be def loop if we were using Arduino, which the Arduino programming environment looks just like this, and I always get the two mixed up as I work back and forth. So I'm going to write some code in here in a minute just to show you how this all works. But think about it like this. This function, it looks like we're defining this for the first time, this setup function. This setup and draw function are built in, but basically their role is the setup function sets up. Let's talk about if we were, this in the context if we were making a game, right? Let's say we were making Pong or some simple game like that. Well, the setup function establishes things that are never going to change in the game. So what I mean by that is the size of the screen, maybe the background color of the screen. Those things set up once, they execute and get set up, and then that's it. We don't have to worry about them over again. The draw function is a little bit different. The draw function contains code that needs to happen over and over and over again. So let's use the example of a game. If we were designing controls, like if we use WASD to move an object on screen, we wouldn't want that code to run just once and then stop. We would want that to happen over and over again. And this draw function loops. So any code that's written in the draw function automatically loops. Okay? We're going to see a little bit about how that's executed in a short while. So first things first, let's set up our screen and let's set up our background color. So I know what the function is to set up the screen size, but I'm just going to show you if we search for size on our documentation, we have this environment section and one of the functions is size, and size defines the dimensions of the display window, width and height in units of pixels. So the function is literally just size, and you can see right here we have in our setup function, we're set in this example is setting a size to 320 by 240. I'm going to set the size to 500 by 500, and we'll see what that looks like in a minute. So if I run this, I actually get an error because I have no code in my def draw section. So I'm just going to put a comment in it. Comment, and let's see if this runs correctly. Nope, still doesn't run. Okay. Well, I'm just going to make a shape. We'll explain what this is in a minute. I'm just going to make a quick shape so our functions will run. So this is 500 by 500 on my screen, and I had created this shape. We'll go into detail on that in a second. Don't worry about it for now. Let's make the screen a little bit larger. Let's make it 800 by 800. That sounds good. There we go. We have a pretty nice size screen now. Very good. So now our screen is 800 pixels by 800 pixels, and the background color by default is just a plain old gray. Let's change that to something else. So the way you change the background color is literally just the word background. And make sure that's background, not background. I can't tell you how many times we've seen students make that mistake. And background, let's see what values that can take in our documentation. I always use RGB, but let's see if there are other examples we can do. Let's see. I can use RGB. I can use RGB with an alpha value, a gray value, value 1, 2, and 3. This is the way I typically run, is with the 3 separate values. Or I can use an image as the background, so we can load an image. We're probably not going to get into that today, but we may get into that in the future. So an example would be like this, right? Background 51, I think that would be a grayscale value. Background with the 3 values RGB, so 255 for red, 204 for green, and 0 for blue. That gives us this yellow color. Or we load a image in, and we're not going to get into that today, but you can load images in, and then you'd basically set the background as the image, right? This is a variable called img that contains loading the image, and all we're doing is say we want the background to be what's contained in that variable. So in our case, we're going to go RGB. Now, this is one thing that's really, really cool about processing. If we go to Tools, there is a color selector. So we got this color selector here, right? And we can actually pick a color, and it gives us the RGB values in real time right over here. And what's also really cool is if we have this on top of the window, it actually stays floating on top of the window. It doesn't get pushed behind like what usually happens. So I'm going to pick like a nice teal color, like maybe something like that. So my values are going to be 45, 247, and 235. And I can come over here and just punch those numbers in. 247 and 235. Those are my RGB values. And close the color picker for now. And now when I run this, I now have my nice teal background, which is awesome. Okay? So these are things that are not going to change. We may actually change the background color depending on what our project ends up being today. We may only get into some basics today, by the way, and we may not make anything super crazy and interactive until a little later. But at any rate, for now, our background's not going to change. In our draw function, that's where we start creating shapes. Now, what's really cool about processing is there are several different functions to create different shapes. In fact, let's go to our documentation and take a look at the different shapes that we can make. We have arc, circle, ellipse, line, point, quad, rect, square, and triangle. So very easy to draw different shapes. If we were making like a really simple 8-bit style arcade game like maybe Pong, we'd probably get away with using some rectangles and using some circles. So we wouldn't even need to make custom sprites in this game. We'd be able to use the shapes that are natively built in. We can probably make some simple iteration of Flappy Bird with the same thing using just some basic shapes. And then we could always upgrade the sprites later on. So let's take a look at the ellipse function. So ellipse would be an oval. It could be a circle as well. And the ellipse function draws an ellipse on the screen. An ellipse with equal width and height is a circle. By default, the first two parameters set the location, and the third and fourth set the width. So an ellipse takes 4 different parameters. The first two set, by default, the first two parameters set the location. So the first two are where the location is on screen. The second two handle its size. So if we go back to our project, and we want to put an ellipse dead center of the screen, well, we can go ahead and put half of our screen size, 400, 400, and then we can put in whatever size we want, and now we have an ellipse in the center of the screen, okay? If we look at the rect function, we can put in a whole bunch of different values. So the rect function draws a rectangle on the screen. A rectangle is a 4-sided shape with every angle at 90 degrees. We knew that. By default, the first two parameters set the location of the upper left corner. The third sets the width, and the fourth sets the height. So again, we take 4 numbers. The first two parameters are going to be its position of the upper left corner of the rectangle. And then the other two set its size. So for example, if I change this to rect, and I have again 400 by 400, and then it's size 50 by 50, this is not in the center of the screen. Even though, you'd think it would set the position to the center because we're taking half of the width. Well, not so. Because its position is determined by the top left corner, we would actually have to offset this. So let's see. We can do that in a couple of different ways. We can do the math to figure out how to change these numbers. So the way that processing works, let's see if I can make this assumption correctly. 425, 425. That actually puts it farther down because the Cartesian plane in processing 0, 0 is in the top left corner, and the numbers move downward like that. So let's make this 375 and 375. Run this. All right, now we're looking more towards the center. But there's another way to do this, and that's using something called Rect Mode, which we're going to quickly take a look at. And what's really cool about the processing documentation is any related functions to any given function are listed at the bottom. So we're dealing with rectangles, and we're trying to get it in the center. Well, it gives you this Rect Mode link that takes you to that documentation. And what Rect Mode does is if we say Rect Mode, got to type that correctly, center, except you have to spell that correctly. And you'll notice that parameters must be written in all caps. So See, I knew that already. If you had written them in lowercase letters, it wouldn't have worked. The parameters must be written in all caps because it's a case-sensitive language. Notice that center turned a different color when I wrote that. Rect Mode center draws the rectangle with its point. These numbers are its center point, not its top left corner anymore. When this is not here, we're going to comment that out. This is now kind of off because the corner's being set to 400 by 400. If I put Rect Mode center, then it centers it on the screen. So any other shape can do the same thing as well. I think there are different modes for the way you draw different shapes. Okay, let's go back. Let's look at some other shapes. So let's look at line. Line draws a line, a direct path between 2 points on the screen. The version of the line with 4 parameters draws the line in 2D. To color a line, use the stroke function. We'll take a look at color in a short while. Essentially, what the line does is it has 2 coordinates for its first point and 2 coordinates for its second point. And then if we put 3 values, we can create a 3D line. So we're just going to stick in 2D today. Let's go ahead and try this out. I'm going to get rid of our Rect Mode center because we're not going to be using Rect Mode anymore. So we're going to create a line, and let's have the first point be 0, 0, and then the second point be 400 and 400. And see what this looks like. So we have from 0, 0, which is the top left corner, going to the center point on the screen. See how handy this documentation is? Anything you need to know, you can find out here. And it all makes pretty good sense, and there's always an example, which is really, really nice. So because we're dealing with the line right now, let's talk about how we fill this. So we can affect the color of a line using the stroke function. And we can also use the StrokeWeight function for a thicker line. But let's just deal with the stroke function. Stroke, when we talk about graphics, deals with an outline. So if you've ever worked in Photoshop or Illustrator and you wanted to put an outline around a shape, you can use stroke to put an outline around that. We're going to use stroke to do the same thing. Basically, we're going to put an outline around our line, which is just the line. And stroke takes RGB values again. So let's go to Tools and go to our color selector, and let's pick a color that looks nice. So we're going to make, I don't know, I'm going to make like a pink or magenta line. That sounds pretty good. Let's make like a magenta line. So our stroke is going to take those 3 values, again, the RGB values over here. So 245, 62, and 205. And now if we run this, we have ourselves a magenta line, which is pretty nice. Let's look at the StrokeWeight function. Sets the width of the stroke used for lines, points, and the border around shapes where all widths are set in units of pixels. So it's an integer, and that deals with the thickness. So let's play around a little bit with that. So let's go to StrokeWeight, and we'll put in an integer of 5 and see what that does to our line. It makes it a slightly thicker line. Let's put in 10. Makes it slightly thicker. Let's put in 100. So it deals with pixels, right? There's no limit. There's no upper end to how thick we can make this line. 50 pixels wide. There we go, right? So that's pretty cool. If we create a shape instead of a line, let's do Rect Mode center. And then we'll create a rectangle, and let's put it dead center. And let's make it 200 pixels by 200 pixels in size. See how I threw an error? Name error, global name center is not defined. That's because I didn't write this in all caps. I got it correct last time, but not this time. So now we have a rectangle with a massive border around the outside. If I get rid of the stroke, we have this 200 pixel by 200 pixel square. If I put the stroke back, then we have our big thick outline. Let's take that outline down and make it 5 pixels so it's less crazy. All right, there we go. Very good. So stroke can be applied towards a line. It can be applied towards shapes, which is pretty cool. Now, let's look at how we fill a shape. Okay. So if I want to fill this rectangle with color, let's check our documentation. I have a function called fill. Sets the color used to fill shapes. For example, if you run fill 2041020, all the subsequent shapes will be filled with orange. Important thing, all subsequent shapes will be filled with orange. So, if I put in a fill of, I'm just going to fill it with green. So 0, 255, 0, because those are RGB values. And I create a rectangle, and then I create an ellipse. And I'm just going to put this wherever, 50, 50, 50, 50. Now, both of those shapes have the same fill. And notice that they both have the same stroke color and stroke weight. Any color effects that we put on shapes, when you look at your code, you can imagine that to color something, you're pouring paint downward on it, meaning that fill cascades downward, right? So any shape that's below this fill line will have that same color. If I wanted ellipse to be a different color, well, I just need to put another fill line on top of ellipse because the fill pours downward. Same thing with the stroke and stroke weight. Anything below that gets affected by that line. So if I put, let's make the ellipse red. So RGB. I run this. Now I have two different colored shapes because I have fill pouring downwards onto rectangle and then a new fill pouring downwards onto ellipse. Let's do the same thing with the stroke. So I'm going to take these lines and get rid of them, right? And I'm going to put those above the rectangle. Then I'm going to do the same thing. I'm going to stroke, let's do, I don't know, I'm just going to make up some numbers, right? And then we'll do the stroke weight. And let's make it 2, right? I now have different fills and different strokes, right? Because these lines apply to what's underneath them. So we basically fill, set the color of the outline, set the weight of the outline, then we draw the shape. Then we set a new fill, or a new stroke color, a new, weight, and a new fill, and that applies to the shape, right? So we can now independently, fill and color the outlines of the shapes, which is pretty cool. So as you can see, very, very easy to draw. Just a few lines needed to start drawing shapes. And what's really cool about processing is the graphics are a little nicer than Turtle. As we were looking at yesterday, Turtle is fine, but the graphics are pretty simple. Because we can import images and do all kinds of cool color effects in this, we can make things a little bit more visually appealing. So that's pretty cool. So I'm going to get rid of this for now. We're going to delete this all. And what we're going to do now is I'm going to fill a shape, and let's fill it with green, RGB. And then I'm going to draw an ellipse. And I'm going to put that wherever. 50, 50, 50, 50 again. We now have our ellipse with no outline. Now, we put in these values for its position, but if we want to make things move on screen, we can't just put a static number inside of the ellipse function, meaning I put 50 in here, that 50 is never going to change, so this shape is never going to move, right? So there are a few different ways that I can make shapes move. One is I could create some variables, and then I could have the variable change each time this loops, and that's going to make the shape loop, which we're going to take a look at in a second. And I guarantee I'm going to mess up that code. I have a feeling I'm going to make a mistake, but that's fine. So we could have variables that change automatically. We could also have variables change when you press keys on the keyboard. We may have time for that. If not, we'll get into that tomorrow. We can also do something really cool that's very similar to Scratch, and we can set the X and Y values of this ellipse function to the X and Y values of where the mouse is on screen. So let's check our documentation here and see if we can find some mouse information. So here are a bunch of mouse functions, and I have mouse X and mouse Y. So mouse X The system variable mouse x always contains the current horizontal coordinate of the mouse. So just like the object in Scratch that has mouse x and mouse y, we have the same thing in processing, which is really cool. So if I come over here and I put in mouse x and mouse y, and I draw, now my shape follows my mouse, which is really, really cool. And the slower and quicker I move these objects, it gives it a really cool 3D effect. Now notice that as I move my mouse, the shape is tiling on screen. It's kind of like the stamp function in Scratch. My shape is tiling on screen. That's because every time this function runs, this draw function runs, we fill the shape, then we print the shape. Then we run it again, we fill the shape, and we print another shape in the same position. If we did not want this to stamp, right? Every time this runs, every time this function runs here, it's basically drawing a new shape. The way that we could fix this is to take background out of setup and have it redraw the background every time this function runs. So think of it this way. It draws the background. Then it draws the shape on the background. Then the function starts all over again, and it draws a background on top of that shape, and then draws a shape on top of that background. So it's effectively masking all of the stamping that's going on. Now, I have my shape moving, which is really nice. No tiling anymore. I kind of like the tiling. It makes for kind of a cool drawing program. So I'm going to put the background function back in setup so that we get our tiling. And there we go. Now we're drawing. Pretty cool. Okay? So I'm going to make the attempt to have the shape move automatically. I'm probably going to mess this up because I'm no expert, but let's see what we could figure out. So I'm going to create some variables up here called xval and make it equal to 0. And that's vval. Oops. Xval and yval equal to 0. Okay? Then I need to define these variables as global variables in this draw function, or else processing doesn't know that these variables exist. By saying global xval and yval, that means that these variables up here apply to this function down here. There might be a better way of explaining that. Throw a comment in, but that's the way I understand it. So instead of mouse x and mouse y, we can put in xval and yval. And if I run this, I have an ellipse at 0, 0, because we had told this function, or told these variables to contain a value of 0, and then we're calling that value contained in each of those variables here, which is 0, 0, so it's up in the top left corner. We now want the shape to move. So after it prints the shape, let's have the xval and yval variables increment by 1. So that would be xval plus equals 1, yval plus equals 1. And we talked about this last time, and I think the time before that, but plus equals takes whatever value is in xval, adds 1 to it, and saves it back to xval. It's basically incrementing. So now our shape slowly moves diagonally across the screen, which is pretty cool. Once it hits the bottom corner, it should just move off screen and we won't see it anymore. And that's that. What if we want to make this move a little bit faster? Well, we can increment it by 5 instead of by 1. So now our shape moves more quickly across screen. Right? Very cool. Now, let's increase that a little bit more. And it flies across screen, right? So if we moved our background function into the draw function, we effectively have what looks like a ball moving across screen. This would be the beginnings of how we might build a Pong game, right? We'd have variables that contain the position of the shape. We could have it start somewhere in the middle of the screen and then move around. We can even have it move in random directions. That would be totally possible. We're not going to get into that today, but this is sort of the makings of how we might build games with processing, which is really cool. So now, I'll show you one other function that's really cool as well, which is we can call a no stroke function, which means that any shapes drawn below no stroke won't have an outline. So now we've got just a, actually that's a terrible color, it blends into the background. I'm going to have it move more slowly so you can see it. So you can see there's no outline on this anymore. This color, these two colors don't go well together. I should have made it red. In fact, let's make the fill red so it sticks out better. We can see this a little bit better. Much better. So now there's no outline. If I take this out, it defaults to a black outline, right? And if I put the background function back in the setup function, then we have our cool tiling effect. I'd be curious to see what that looks like with the no stroke function called. Let's see. It might give it like a cool... Oh, it looks like it's drawing a line. That's kind of cool. I like that. So different effects for different things, right? Very, very cool. So now, I'm not quite sure what we're going to do next. Let's try this. So we know that the size of our screen is 800 by 800. I'm going to put this background function back in my draw function because it's going to make the effect better. Why don't we put in an if-then statement that says, an if-else statement that says, if, we don't even need the else, just an if statement. If the xval and yval variables are larger than 800, go back to 0, 0. That sounds like a good one. So we would write if xval is greater than 800, then we're going to set xval back to 0. So the value of xval will start as 0. Each time the draw function runs, we're going to increase xval by 1. And as soon as xval is larger than 800, which is the size of our screen, it's going to reset back to 0 and go back to the beginning. Okay? We can then say if, we could actually combine these into one if statement. We could say if xval is greater than 800 and yval is greater than 800, then we can put xval and yval both equal to 0. But that works well because we're moving in a diagonal line. But if the ball was not moving in a diagonal line, we don't want both of these conditions to need to be met for it to reset. We would want to separate these. In other words, let's say we had the ball moving kind of directly downwards, kind of like this. Well, the values wouldn't reset unless the ball got all the way over to the corner. So it could exceed 800 going down, and it would keep moving down way off screen until both of those values exceeded 800. Then it would reset. So because we're moving in a perfect diagonal line from the top left corner, this is fine. But if we weren't, we'd want to put this in a different if, which is what I'm going to do, just in case we change the way that the ball moves. So yval is greater than 800. I hope that made sense. We're going to change yval to 0. So let's start with this on its own and let's see what happens. So the ball moves across the screen diagonally from 0, 0 down to the corner of the screen, and we are getting there. I probably should have increased the speed a little bit, but that's okay. So we get down to the corner, and as soon as that happens, hey, we reset. So that's kind of cool, right? So now we can have an infinite loop of this moving on screen. If I put the background function back here, I'm actually going to speed this up a little bit too, so we don't have to wait as long for it to run. Now, it actually is still moving, but because we don't have the outline, the stroke applied to this, we actually don't see anything. So let's actually play with this a little bit. We're going to get this to like draw stripes. So let's make this... Actually, that's not going to work. All right, you know what? Forget it. I'm going to stick to my other plan. Let's put the outline back on and see what this looks like. So there we go. We see it passing through, right? So for any kind of game that has moving objects, you're definitely going to want the background function in the draw function. Okay. So we can take this off, and let's put the background function back in here. And now we got the ball moving across. Okay. Very cool. I just want to quickly explain what I was talking about with the if x val is greater than 100 and y val is greater than 800. We could actually write that another way that would work really well. So the ball comes directly across, and it's going to hit the x value and y value are going to hit 800 at the same exact time because we're starting at 0, 0, and we're increasing the number equally, right? So the y value and the x value are increasing by 5 equally, right? But if we had the ball coming down this direction, right, the y value is going to hit 800 before the x value hits 800. And if the code was written, if x val and y val exceed 800. Oops, I got to put the right symbol in. Right? If we wrote it like this, and the ball came down this direction and hit the y value of 800 here, it would actually keep moving down way off screen until both x and y exceeded 800 before it reset. Now, there is another way we can write this to get this to work either way, which is to change and to or, which basically means that either of these conditions can be met, either one, before they reset. So that means it could exceed 800 here and it would still reset, and it could exceed 800 here and it would still reset. And we're going to test that. And the way we're going to test that is we're going to increment the x value by a value larger than the way we're going to increment the y value. So now, see? So it resets because the x value is exceeding 800 here, but not the y value. But the if statement doesn't matter if either one of them is met, as long as one of them is met. So we're going to do the same. I'll set this to 5 and this to 15, and we should see the same exact result, right? So the x value never gets close to 800, but because the y value exceeds 800, it triggers what's inside of this if statement. So that's something really useful. I should have thought of that before, and I didn't. I have the tendency to write code super inefficiently and then realize that I can do a better job. But I thought of it pretty quickly, so that's pretty good. So we can use that or keyword to determine that. Very cool, very cool. Let's do one more thing before we wrap up for today, which is to make a little drawing program. Very simple. So I'm going to get rid of this. And, no, you know, I'm going to get rid of this stuff. I'll get rid of everything. I'll get rid of everything. So I don't need x val and y val. We can get rid of those. I don't need this anymore. And I'm going to put background back in setup because I want my shapes to tile. So I don't want any outline. And then I want to fill my shape with, let's make it red. So 255R, 0 for G, 0 for B. And then I'm going to make an ellipse that goes mouse X and mouse Y. So those are its coordinates. And then we'll make it 100 by 100, okay? So now we're back to this where we have our little drawing program here. I think 100 by 100 is too big. Let's do 25 by 25. All right, now I have this little, that's too small, 50 by 50. Split the difference. All right, cool. So now we're in business. Now I can draw with this red shape, right? I can draw a bunch of stuff like that, which is pretty cool. So what I want to happen now is I want to simulate the ability to erase my drawings using the mouse button. So basically what I'm going to do is say to the computer, when I'm just drawing around like this, this shape is going to be red. But when I press the mouse button, we're going to change the fill of the shape to the same color as the background. So in reality, we're drawing on top of the red with a new shape that's the same color as the background, but because we have no stroke, it will look like we're erasing our drawing. So let's refer to the documentation to figure out how we can use the mouse clicked, right? So we have a mouse pressed function, and that's going to work pretty well for us, right? So the mouse press variable stores whether or not a mouse button is currently being pressed. The value is true when the mouse button is pressed and false if no button is pressed. So this is really nice that this is built into processing, because if we were using the keyboard for this, we would need to check to see if a key is pressed, and we would need to check to see if the key is released. We're going to probably get into that tomorrow, but because we have this mouse press variable, that automatically contains either true or false if the mouse is pressed or not pressed when we're running our program. Okay, so we're going to basically we're going to write our code just like this. We're going to say if mouse pressed, fill so-and-so, else fill another color, right? Which actually means we're going to change something. So basically, what we're going to do is write if mouse pressed. If the mouse is pressed, that's going to be our eraser. So we want to fill our shape with the same color as the background, right? So when we press the mouse, it's the same color as the background. Otherwise, we want our shape to be filled with this color. So when the mouse pressed function returns false, or in other words, the mouse button is not pressed, that's our else, and we're filling our red color. If the mouse pressed variable returns true, which means the mouse is pressed, then we're filling the same color as the background. This true or false thing is called a Boolean. It can either have one of two values, on or off, yes or no, true or false. We're going to use that a bit later when we start messing around with keyboard input. But assuming I didn't make any mistakes, we are now drawing with our shape, and then when I press the mouse button, it effectively looks like I'm erasing my my shape here, right? And then when I let go, I start drawing again. We could also do the opposite. We could fill with the red when the mouse is pressed and fill with the shape when it's not pressed. So we're just reversing what we had done. So now nothing happens, and then I can click and draw, right? So I can do this, and then make a smiley face or something. Or I can erase stuff, right? So that's pretty cool. So that way I can kind of control my drawing a little bit more. Kind of neat, kind of neat. So, okay, cool. So we have a little time. Let's add one other element to this. Let's take a quick peek. I think what we're going to do now is we'll set a key to erase what's on screen. So if we draw a bunch of stuff and you don't want to take the time to erase it, you can just press a key and erase everything. So dealing with keyboard input is a little more complicated than what we're going to do today. We're going to basically do something really, really simple, which is basically doing something similar to what we did with the mouse. The Boolean system variable key pressed is true if any key is pressed and false if no keys are pressed. So basically the same thing with the mouse. When the mouse is pressed, it's true. That's when we're drawing. When it's released, it's false, and then we're no longer drawing. Here it's the same thing. If we press a key, it returns true. When we release it, it returns false. This will work in our case because we don't care what key you press. It's just detecting if any key is pressed. If we were making a game and we had different kinds of keyboard input, this function would not help us because it checks if any key is pressed. What we're going to have to do later on is use the key pressed and key released functions. We're not going to get into that today. It's really not that complicated, believe it or not. But for now, we're just going to use this key pressed variable, right? This Boolean system variable key pressed. So what I can then do is I can say if key pressed equals true, and it's true with a capital T. So we're checking to see if key pressed is true. Then we're going to clear our screen. So now we're drawing, and if I press any key, my screen clears. Now what happened here? The whole screen turned black when I pressed the key. That's because we've only drawn our background color once. And by clearing the screen, it never runs this function again. So it defaults to making a black background. So what we can do to prevent that from happening is just create the background all over again in this function when we press the key, in this if statement. So we're just going to put in those same values, 45, 247, and 235. And now we can draw, and then I can press any key, and it clears the keyboard and fills in the screen. So I think we're going to wrap up for today. I think that was a pretty good starter into processing with Python. In the future, we're going to look at using some keys to control things on screen, make things a little bit more interesting, probably defining our own functions as well. We may also look at processing with Java just to see how it's written a little bit differently. Very similar, it's just a couple of different rules. For today, just to review, we talked about installing processing, and we also talked about installing the Python mode in processing. We talked about the setup and draw function. So the setup function runs one time at the beginning of your program and then never runs again. The draw function runs in a loop. Anything inside of that will repeat over and over again. We talked about creating different shapes. We saw there was a circle function, square function, rect function, all that good stuff. We talked about the parameters that those shapes take. We talked about filling the shape with color, which fills downward, and as well as creating an outline or no outline, and the size of that outline. We also looked at clearing the screen, taking some mouse input, and key input. We're going to go into more detail about that in the future. The other thing, just really quickly, I want to point out is we did talk about the reference documentation for processing with Python, processing.py. The website is py.processing.org/reference. This is the most amazing resource that gives you great information and great details of what's going on. So if you do want to take it upon yourself to start playing around with processing with Python, use this as a resource. It's great. Keep in mind also, if you're interested in diving into a little bit more detail into using processing to create graphics with code, we've got some great online classes for that. We teach a really cool class called Arcade Game Design, which creates vintage-style arcade games like Pong and Galaga and Pac-Man, those kinds of things, using processing. We also have a drawing with code class, which is using Python to do the types of things we've done today in a bit more detail. So definitely check that out. We've got a ton of new online classes coming soon, so definitely stay tuned to our website and social media. And I thank you very much for joining me this afternoon. I look forward to seeing you tomorrow, and I hope you all have a great day. Thanks so much.